our new stuff for today. What we're going to look at today is factoring quadratics again. So that's why this is really kind of more of a chapter 5 thing, that we're going to factor stuff that's like ax squared plus bx plus c. But before, when we did this, we never had a number in front of the x squared. So now we're going to look at how it works when there's a number in front of that x squared. First step, always, 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 cannot emphasize this enough. I thought I emphasized it enough in the last class, and then they started doing their homework and it wasn't happening. Cannot emphasize this enough. First step, always divide out something in common. So if there is something in common, get it out of there. That makes your number smaller, easier to work. Okay? If it's not possible, that's fine. You just don't do it. But always check. And if there's something in common, very first step, divide it out. So is there anything that divides into 2, 11, and 12? 2, 11, and 12? No, close 2 and 12, but 11 being odd doesn't really work out that way. So nothing to do on this problem, but it's always the first thing you check when you're factoring. Then, determine your A, B, and C. Same as we did when we did x squared. B is with the x, C is the constant. Then what we're going to do is it says multiply A and C, and we're going to call that D. That's 24. Take A and C and multiply them, and that's going to be a special number for us in this problem. Step 2 says make a list of numbers that multiply to be D, that 24. And then we're going to look through their sums to find something that adds to be B. This is familiar to that first type of problem that we did, where we're looking for a list that multiplied to be something, that added to be something else. This time, though, we're going to multiply to be the D value instead of the C value. Now, when we did this before, we never had to worry about that because A was always 1. So this still works if A is 1, but then, C and D would be exactly the same thing. So this is just kind of a new element to that problem when we have an A value. So we're going to make a list of numbers that multiply to be 24, that add to be 11. I think you have a chart to put this in your notes, but I don't. I need to pick the pair of numbers that I can make an 11 out of. So what's that? 8 and 3. Do I want them negative or positive? Positive. Both positive, because I want a positive 24 and a positive 11. Step 3 says rewrite the trinomial. Trinomial just means try 3 things, nomial things, really. So it's a 3-termed thing. So we're just going to rewrite the original question, replacing the original middle term, that x term, with the 2 things we just said we could add up and get it. So instead of writing 2x squared plus 11x plus 12, the original problem, we're going to write 2x squared plus 3x plus 8x plus 12, because 3x plus 8x is 11x. So we haven't changed the original up that middle 2 parts. So instead of calling it 11x, we're breaking it up, choosing the numbers that we did from the chart. And there's no work like that in math, and you can't make a wrong decision. So you can pick the wrong numbers out of your list, but once you've picked the right numbers, it doesn't matter which way you plug them in. 3 and 8, 8 and 3, either way it works. The last step says factor by grouping. So we're going to take this thing now and factor by grouping. Group up the first 2 terms, group up the last 2 terms. What is in common in those first 2 terms? An x. Leaving 2x plus 3. What's in common in the second group? 4. Leaving 2x plus 3. Like yesterday when we factor by grouping, those groups always have to match. And I would urge you to not be like, well, my groups have to match, and just write. Check your work. If you do this, that means you made a mistake somewhere before this. So that's a really good check mark for you to be like, okay, they match, I must be doing it right so far. Then write the matching groups times the leftovers, and that's our final answer. If we would FOIL that out, we get the original question. Okay? Let's do some more practice. First step, always, 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 first step, look it's evenly out of everything. Is there anything in this question? 2. So get it out of there. Take out a 2. What's left when we divide a 2 out of everything?
3x
Don't let the 2 disappear. Now we don't have to do anything with it other than just let it tag along. Okay? So it's just going to hang out in the front of the problem all the way through to our answer. Don't lose it, but you don't have to mess with it anymore. And now our numbers are smaller to deal with. So next step was to make a list of numbers that multiply to be something. What should they multiply to be? A times C. So 3 times negative 10 is negative 30. That's what we're looking for numbers to multiply to. So 1 and 30, 2 and 15, 3 and 10, 5. Which set of those in some way can I make a negative 1x out of? Plus 5 minus 6. We'll add to give me a negative 1 and multiply to give me a negative 30. So our next step, 2 tags along. I like to use square brackets at this point, but that's the thing. Several sets of parentheses, so for me this just kind of helps make a distinction. We're going to rewrite now that middle term as plus 5x minus 6x. Excuse me, instead of the original minus x. So we're going to break up that middle term into the 2 numbers we picked from our chart. By grouping. Group together first 2 plus last 2.
It doesn't matter what order they're in?
It does not. Nope. If you do negative 6x plus 5x, you'll get the same thing in the end. 2 keeps tagging along. What comes out of that first group? That first one is negative. We're going to take the negative as well, so we're going to take out a negative 2. What's left when we divide by negative 2? Positive 3x, positive 5. Negative 10 divided by negative 2 gives us positive 5. That, which is good. Things have been going well so far. So our final answer is going to be that 2 that's been tagging along, the 3x plus 5 that matched, and the x minus 2 that we have left over. If we would FOIL and distribute all of that back through, we should end up we will always have linear terms to simplify further, unless, I suppose, one thing that it might be a good idea to check is just to make sure that no number divides out. That could happen if you forget to divide out as your very first step, then you might want to do that as your very last step. But as far as like factoring down further like yesterday, since there's no squares in here, they won't factor down further.
I'll answer outside bigger brackets. That not change?
It doesn't change the answer. Multiplying, it doesn't matter what order we multiply, so we don't need to keep that grouped, but it's not wrong to keep it grouped.
Say like we didn't factor out the 2 at the very beginning. Would we get a wrong answer if we factored it out at the very end?
No. You could either factor out the 2 at the very beginning, and then you'll have smaller numbers to work with. But if you don't notice it, then in your very final step, one of these groups would still be divisible by 2. So it might have been something like 6x plus 10, and we could take the 2 out at that point.
Yeah.
So you could either divide out a constant factor as your first step or your last step, but it's easiest if you do it first because then your numbers are smaller through the whole problem. Why? Anything more? Is there a number? No. Okay, so 6, 7, 5, they don't divide by anything. Is there an x in all of them? I'm probably feeling like this is a long process. And it kind of is, but what happened with guess and check? So if I were to try to factor this down now with guess and check. Okay, what could I multiply? Matters. So for each of these pairs, I would have to check 1 and 5, 5 and 1, 1 and 5, 5 and 1, 1 and 5, 5 and 1, 1 and 5, 5 and 1. This is a relatively short list of things because 6, there's only 2 ways to do 6, 1 and 6, 2 and 3. And 5, there's only 1 way to do that. So this is a relatively short list of possibilities as far as guess and check goes. 24 is like the worst number ever because pretty much everything divides evenly into to have 24 groups of any size. Let's practice that process again. What are we making a list of stuff to multiply? I add in some way to get a negative 7. A 3 and a 10, positive 3 and negative 10 will give me negative 7. Comes out of that first group? 3 and x. What's left? Plus 1. Okay, so if you divide everything out, we're dividing. So 3x divided by 3x is plus. What comes out of the second group? Negative 5. What do I get when I divide by negative 5? 2x. Good sign. So right up tagging along, the 2x plus 1 and the 3x minus 5, which, by the way, I think was one of the last things in that list. So if I went in the order of that list, questions?